Whoa. What's up y'all, how y'all doing? Now, before I start, let me tell you a little story. A few years ago, in a library where I was learning in a school, I found this book, and when I later read about it, it is a radio transmitting circuit of like a technology that they were using a long time ago, probably 100 years ago. And what it says was spark gap transmitter. And today I'm gonna do exactly that. And hopefully you'll learn this tech and use it for yourself. Now, according to my research, a transmitter consists of mainly three components: a capacitor, an inductor, and a high voltage source, and possibly an antenna. The way it works is very easy, well, relatively easy. The point of having a capacitor and inductor, and as you all know it, is to create a resonance frequency. Spark gap acts as a switch for the RC circuit over here. So while for each spark that is created, the circuit creates a resonance frequency just like this one. It starts big and it starts small due to the capacitive resistance and the light. Now, I'm not gonna go into that deeply because I've made it in my previous videos. Main part is this antenna. Now, while that happens, when this resonance frequency is created, that resonance frequency will generate an electromagnetic wave through this pole or terminal. We call it an antenna. So what happens is, every time a current passes in and out and slowly dumps away, electrons push back and forth in this antenna. And that creates an electromagnetic field through the air and create what we call it a signal. And that energy is transmitted through air. And that is why we call it a transmitter. So this is exactly what we're gonna create. Let's get started. Oh, and before you do this experiment, please like, share, and subscribe to my channel, please. You see, I got a problem. I don't have a measuring equipment. I don't have a multimeter, unfortunately, but I promise you guys I will buy one day, soon enough. And the second one is I don't have a suitable equipment. For example, inductor. In the case of inductor, usually when you salvage an inductor, you don't know how much its inductance is, so you have to guess, or you have to calculate, or you can measure it, which I currently can't. So I'm gonna make my own inductor. And I have my own specific capacitor. They are labeled always. And spark gap, it can be done. And antenna, it's no problem. It's just a wire. So we're gonna, well, mix them up and see what will happen. So yeah, this is an inductor of unknown value. And I honestly don't know how much inductance this thing have, but I have to assume it's very, very small. Really small. And probably in nano scale. So yeah, there we have it. Now, the reason that I made some spaces is because of the high voltage. But also I'm going to tell you why I'm not going to measure how much inductor it's going to have. My next material is going to be a capacitor. Since I'm dealing with a high voltage, I'm going to be using this capacitor of 2200 picofarad. We're going to use this new inductor that we made, a spark gap, which easily you can make, and a high voltage source, which I'll be using my old friend here, my old ZVS and Flyback transformer circuit. We're gonna connect them and see what will happen. Okay, I connected everything as the schematic says. I've connected the capacitor to the inductor, to the spark gap, and to my high voltage supply. Okay, now this is a better view. There's the ZVS driver with the flyback providing high voltage through the spark gap and inductor connected. And parallel, there is the capacitor, and all the way up, yeah, we connected it. Now, the biggest question is, will it work? Well, let's see. Alright, that's loud. That's loud, yeah, I think it works. The capacitor works. Everything is functional. Here is all you need to, well, understand what I'm talking about. Now, there is this transmitter circuit that I've, well, in detail explained, and this one is the receiver circuit. Now, we all know that a transmitter will emit its own frequency that we call a resonance frequency, that is specifically caused with the capacitor and inductor circuit. Now, while that happens, we calculate the frequency emitted by the transmitter. What we will do here is we don't need to measure the inductance of the transmitter here, because if we want to build the receiver, we must do exactly, or we must design the exact same inductor as the transmitter one. So whatever we do, if we keep the same capacitor and the same inductance, we'll find ourselves in something called a tuning. Okay guys, now I've made this tiny receiver exactly to the schematic that I showed you. This is a loop of wire and capacitor of the same design, the same inductor, the same capacitor, and I just put only one diode because it's enough to show you guys what it means. Now, what I'm gonna do is show it to you like this while bring it closer. Now, I want the radiation to be captured by this system and light the LED. Let's do this. Can you see it? Is it visible? it has lights. Ew. Yes, it works. When you bring it closer, it gets light. When you bring it a little bit far, it starts to dim. Okay guys, over there you can see the LED light because of the wireless transmission of power. So we're gonna put it over here. No connections. I'm not cheating on anything. There's nothing below here. Damn, it's dark. Anyway, there's nothing here. It's completely proof. Now I'm gonna put it right here, and when this spark is lit, the LED must light as well. The LED lights as well. Now, let's turn it on. You see that? It lights. Okay, now, I personally say that I achieved a wireless transmission of signals or information. Alright, now let me show you by what I mean by a factor of inverse. For example, if I put it a bit far distance, such as that. Now, if I put it way over there, you can see if there is any light or no. You see? There's almost no lights, which means the distance affected. But if I bring it closer right here, you see, it begins to light. That is what we call the inverse square relationship. As you increase the distance, the factor is divided by squared. Now it doesn't light at all. Okay, let's bring a little bit closer. You see that? You see the distance? See that? The LED tries to light. Yeah, so this, ladies and gentlemen, is the way of how radio works. And as you all know, send signals via telegraph. And you know what telegraph is from the different movies or even from your personal knowledge. And it's basically the same way that this works. They send signals, which is interpreted into a meaningful code, the Morse code. So, as a quiz, let me send this Morse code and you tell me what it means and write it down below. And thank you for watching very much and see you next time.